Hello everyone and welcome to the course of Research Methodology in Natural Sciences. So this is week 8 discussion here and so today we'll be discussing, but before that there were some questions on error propagation. So this is the first one. Okay, I think I will have another one, but this is the first one. This is from the book Research Methodology in Natural Sciences, the same book, and you have to solve it. Okay, so all the things are essentially given, and yeah, take your time to solve it. You guys are solving, yeah? Till that t equal to is the time period, yeah, and L is the length, and that's what, and the equation t equal to 2 pi into L by G. Yeah. So what we can do is we can take out the value of G. Yeah. So what will be G? If we take it out, t by 2 pi equal to root L by G. What we can write is G equal to 4 pi square L by T square. Just rearrange it. And then if you put the value of pi, okay, or otherwise you put the L value, 0.381 divided by T square, which is 1.24. What we get is, how much we getting? Anybody getting anything? You all calculated this or what? So what we get is 9.78. This should be meter per second. Now to calculate the, so this is the absolute value, okay. So calculate the error, you can find G equal to this same equation we will take, and then we will differentiate it. Pi square. So dg equal to 8 pi square L t by dt. So here we have the value of dt, okay, which is 0.1, and this also we have here 0.381. This is also given 1.24. So everything you will calculate, you will get is minus 0.07 meter per second. Okay. So standard error is equal to standard deviation by number of observations. Yeah. So here this you will put as so what we will do is you will divide it by divide this value with 25. So the length will be so you can put 9.78 plus minus what will be the this dg by so it will be 0.0028, or you can write 9.78 plus minus 0.03. Okay, understood you all? Okay. Any doubts you can ask? Okay, then we go to the next one. This was another question. I think the first two parts were solved. The last one remained, yeah. So if anybody has done, they can tell. Otherwise, we'll solve it. Okay, so the Q, the first ones were calculated already. Yeah. So the mean here is important for the third section. Mean is 5.433, and standard deviation is 1.7437. So standard error is 1.7437 divided by root 25, that is okay. So what we can write is we can find the significance value. Yeah. So what will be this is You can find x minus mu. So x will be 7.5 minus 5.433 divided by 3487. So the answer will come as this one. So this you have to check from the significance table. Yeah. So what above what value this one will have. So that you have to see from the table. Okay. So that was how we have to do it. Coming to this week's topics, it was hypothesis testing, basics of hypothesis testing, z-test, t-test and chi-square test. So hypothesis testing is all about, so first to define as hypothesis, it is an assumption, an idea that is proposed for the sake of argument so that it can be tested. It is usually a tentative assumption or suggestion made strictly for the objective of being tested. So there are some examples of hypothesis. If a person sleeps at least 6 hours, the person will be active. Then if the person sleeps less than 6 hours. Here's one. If a ball is dropped, it will fall towards the ground. So like that you can have multiple hypotheses. The types of research hypothesis. So a research hypothesis is a statement of expectation or prediction that will be tested by research. In hypothesis, the relationship between variables is predicted. Okay. So there are two types of hypothesis. One is null hypothesis. So in null hypothesis, it states that there is no relationship between two variables being studied. And then there is alternative hypothesis. The alternative hypothesis states that there is a relationship between the two variables being studied. So the alternative hypothesis typically denotes with these symbols here, and okay, and using less than, greater than or not equal symbols. Okay, if the null hypothesis is rejected, then it is assumed that there is enough evidence to support the alternative hypothesis. A z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. Okay. It can be used to test hypotheses in which z-test follows a normal distribution. Difference between z-test and t-test. Z-test is used when sample size is large or the population variance is known, and t-test is used when sample size is small. The important thing is a scientific hypothesis must be testable, and a scientific hypothesis must be falsifiable. That is, these are the important parameters that should be there in scientific hypothesis. So testing procedure, yeah. So you have to specify the different hypothesis statements. You have to set the significance level like 95%, 90%, 99%, and calculate the test statistic and corresponding p-value. Okay, and draw a conclusion by comparing the both the values. Z-test, here it is Z-test. Yeah. So in Z-test, it is mostly used for large samples. The population is assumed to be normal distributed, and the sample the sample distribution of the mean is normal distributed. Okay, and this is the formula: sample mean minus population mean, 100 error of the mean. Yeah. Or you can also tell observed mean, expected mean, and standard error of the mean. So if the area under the normal curve corresponding to the value of z is less than the stipulated confidence value, then the null hypothesis is not rejected. Okay. Okay. And if the area under the normal curve corresponding to the value of z is greater than the stipulated confidence value, the null hypothesis is rejected. Okay. If the calculated z is less than the table value at the given level of confidence, the null hypothesis is not rejected, and it is vice versa. So it's kind of a simpler version of this statement. Similarly, there is t-test. A t-test is a statistical test used to compare the means of two groups. The t-distribution data follows a bell curve when plotted on a graph with the greatest number of observations close to the mean and fewer observations in the tails. Okay, so these are the tails and these are the closer to the mean. Yeah. The t-distribution is a type of normal distribution used for smaller sample sizes where variance in the data is unknown. The variance in a t-distribution is estimated based on degrees of freedom of the data set. So degree of freedom is total number of observations minus 1. The t-distribution gives a lower probability to the center and a higher probability to the tails than the standard normal distribution. Okay. So it's often used to find the p-value for a confidence interval of a statistical test on the given data. Okay. Then there is also chi-square test. So it was introduced by Carl Pearson in 1990. So chi-square test is related to the standard distribution. If a random variable x has the standard normal distribution, then x square or chi-square has the chi-square distribution with 1 degree of freedom. Okay. So it is a multinomial distribution. It is used to determine whether observed data comes from a given theoretical distribution, hypothesis testing, or you can also test whether the attributes in a given contingency table are independent, or we say it's goodness of fit. Okay. So this is the formula of a chi-square. Okay. So here O, O1, O2, O1 is set of observed experimental frequencies, and E and E2 are the corresponding expected or theoretical frequencies. In this case, null hypothesis is that there is no significant difference between the observed values and the corresponding expected theoretical values. And if the null hypothesis H0 is true, the test statistic follows chi-square distribution with n-1 degrees of freedom. So let's our questions. So very low birth weight babies continued IQ scores were available for 1-3 men in the VLVW group. Okay, the mean IQ was 87.6 and the standard deviation was 15.1. So 106 men in the control group has mean IQ of 94.7 and with standard deviations 14.9. Is there a good evidence that mean IQ is lower among VL, like very low birth weight babies, than among controls from similar background? Okay, so this is a test. This is a Z-test question. So we can set the p value as 95%, for which z is 1.96. remember this, that the calculated z is less than the table value at a given level, the null hypothesis is not rejected, and if it is more than the table value, the null hypothesis is rejected. So you have to keep in mind. calculating the z score here. So we have to find the mean, difference of the mean. Yeah. So we have two kinds of mean. Okay, so here what will come is the first mean 87.6 minus 94.7 divided by 15.1 whole square plus 14.9 whole square 106. So it will come as minus 7.1 2.027 to minus 3.4. So it doesn't matter anyway, it is modulus. So now the statistic value was 1.96. Okay, so the calculated value is more than the table value. So what we can conclude is that null hypothesis is rejected. So we can say that there is relation between the mean IQ and very low birth weight babies. Yeah. Okay. So going to the next one. Similar question. In an investigation on neonatal blood pressure in relation to maturity, which results were following are the results were obtained. Okay. The normal and neonatal asphyxia. Okay. So all the number, mean and standard deviation is given. So similarly you have to find the relation. So this you can consider as the control group. This one as experiment. This one test. So it's a similar question. So we'll calculate the z value. So x1 minus x2, these are the means. So it's 75 minus 69 means 56 plus 54 is 25. 6 minus so this is the statistic value. So similarly it is greater than the test value, that maybe for 95% z is 1.96. So null hypothesis is rejected. Yeah. Okay. So suppose a scientist wants to test if the theoretically predicted character of a black body radiation is indeed correct. She measured the intensity of radiation emitted by a black body at 10 different wavelengths. So this is a chi-square test question. So you have to find the goodness of it. table value here is 18.307.
Hello, sir.
Yeah.
Sir, can you please explain this chi-square test?
Huh?
Can you please explain this chi-square test condition?
Yeah. So there we'll have two tables. Yeah. One will be observed. One will be the expected. Okay. So you have to find the. Uh, so you have to put it in this formula and then test. Similarly, it's a test. You will get a number, chi-square value, and then you have to compare it with the table value. If it is less than that, same null hypothesis, rejected null hypothesis. It's the same hypothesis testing, but then you have to see it in that way. Okay. So this is the two frequencies that is given. You have to put it there and see it. So here you have two, na? So whenever it is written, so it's the chi-square I've already written. Yeah, it's like you have to find when they will tell to find the goodness of it. Like here it is written that relations is indeed correct or not. Then you have to find the chi-square. And when you have to find the difference between two groups of data, whether they are related or not, then you have to use z-test. And z-test and t-test, you have to depend on the number of samples or if the variance is given or not. If the variance is given, then you should go for z-test, or otherwise you will go for the t-test.
Sir, if variance is given, then you have to go for
Z-test.
z-test, or else we will be sticking with t-test.
Yes.
Okay. Yes, sir. And sir, these values means the table which is given, that I'm not able to means how the values we are going to take means.
Okay. Mostly these values will be given in the question, or otherwise they will be given in the table. So reading the table and all, you can take help of YouTube actually. How to read the Z table and how to read the T table, like that. It's like there will be two columns depending on the decimal.
Sir, that Z table and T table I'm comfortable with. I'm not comfortable with this chi-square. Yes.
Because there is another parameter called as degree of freedom coming.
Okay.
So yeah, just you just to go for it. Actually, I don't have the table. Otherwise, I would have shown. But yeah, you go through it. If you don't find it, anyway, we can see it in the next one.
Yes.
So here you have to have two hypotheses. Okay, the null hypothesis is that the theoretical prediction is correct, and the alternative hypothesis is that it is wrong. Okay, so now you have to, depending on that, you have to put this test. So you calculate the chi-square. Chi-square formula I have given here. So it will be like chi-square equal to. So here you have observed mean and expected mean. Okay, so it will be like 4.02 minus 2.13 square divided by standard error. Okay, so it will be 1.21 whole square. Like that, you have to add all the 10 values here. So you will get the statistic, chi-square statistic value. Then you have to compare it whether it is less than 18.307 or not. No, for this, when you are comparing it with expected, like when you are using chi-square for comparing measurements with expected values, yeah, then you have to use standard error. So that's just the formula for it. But when you are comparing measurements with expected values, you have to add the standard error. Like use standard error in the denominator. You all calculated all the values or? Okay, so I hope everyone is calculating it. Okay, so the answer here will come as 14.177. So what is the test value? Yeah, this I have already given. Okay, so this is less than the table value. So we told that null hypothesis So since the obtained value for test statistic is 14.117, which is less than the critical value for rejection, we have to say that the experiment does not provide any ground for rejection of the theory. Okay. Yeah, correct. The null hypothesis is accepted. When we define the null hypothesis, is that theoretical prediction is correct. Is it a Karthik? Is it a homework question, like assignment question? That then I can't help actually. That because I have guidelines to not help.
No, sir, I'm not asking for the solution. Just guide me how to go about, because it is asking for some probability case, sir.
I'm not aware what the question is, but I can't
No.
actually help also. I can only give you similar questions, and that's what it is. But if you, I am not aware of the question also actually. That's it.
No question, I can put it in the chat box, sir. Just
Okay.
like guide me how to go about. I don't want to solve the questions.
Okay, you can put it. No issue. I'll see how I can. Okay. Suppose scientists have hypothesized that a substance E decreases the possibility of infection by COVID-19 virus, that is, it acts as a vaccine. You want to test it in two separate laboratories if it is really effective. You gather a number of people. You apply V on 220 people in lab A, 200 people in lab B, and the placebo on 200 people. After a year, you take a survey and find out. I think I didn't get the total question now.
Okay, one second.
Okay. Out of those who got V in lab B, it is got sick. Out of people who got placebo, 50 got sick. What medical reach regarding efficacy of drugs needed to reject the hypothesis. I'll show the next question. Till then I can help, and you all can solve that one, and then I can maybe help with this. I'll see if I can. So it's kind of a similar question. So I can only help you with similar questions, but yeah. But that so yeah, maybe you solve this. Maybe you can solve this one. It's okay. The theory predicts that the propagation of beans in 4 groups A, B, C should be 11:4:3:2. In an experiment, it was observed that the number of 4 groups A, B, C, and D are 1070, 430, 330, and 170. Does the result of the experiment support theory? Value of chi-square at 5% level of significance at 345 degrees of freedom are 7.815, 9.488, and 11.070. Which formula to use? I can't directly tell you. That's the issue. I have instructions to not actually help you with any questions, any assignment based questions. So that's what. You can ask me some concept based that we can discuss together, but direct questions are something that is kind of prohibited. So I can only tell you one thing, that make the table, yeah, that expected and observed frequency table, and that's the go ahead. So you have to find out how to reach that table, and after that the question is kind of simple. That's what it is. Okay, let's see it. So so it's kind of a good question for the one you asked, actually. So here you have to make the expected frequencies and of that frequency of individual groups. So this is the total number of beans, the observed number of beans, okay, and then you have to find what is the expected number of beans in group A. So like that you have to find the expected number for each E, B, C and D, okay. So yeah, then you will find that test statistic is the chi-square, yeah. So you will find the value which comes around 10.5682, 5682 that one of you have answered. So so the degree of freedom is 4. Okay, so the calculated value chi square is more than the given tabulated value, that is 9.488. Hence the null hypothesis is rejected, and it is concluded that the alternate hypothesis is accepted, that the theory supports the experimental methods. Okay. So that's all. I think you try the that question. I hope you all will be able to solve it. Okay. I can't help more on that. That's right. Is it okay, everyone?
Well, by sir, but problem is here straightforward ratio is there, but in the VK questions there is no ratio.
But there also you have to find the expected number. That table formation is the main catch. Okay, that's what I can tell. More than that, please don't ask me.
Okay.
Yeah. Okay, I think that's what I kept less questions because it is mathematically intensive more. So I can't put more questions actually. Saturates kind of. Okay.